Hello guys, welcome to Algo Insights. Today we'll go through another lead code problem, palindrome number. The problem description says, given an integer x, return true if x is a palindrome integer. An integer is palindrome when it reads the same backward as forward. For example, 121 is a palindrome while 1 is not. And examples 121 palindrome. For negative numbers, they are mentioned. We read from left to right. We read it as minus sign and 1 to 1, but from right to left it becomes 1 to 1 and the minus sign. So therefore it's not a palindrome. So basically any negative number will not be a palindrome. Uh, Palindrome, if you know for a string, it's the same way that is read as forward as backward. In the example they have clearly mentioned 1 to 1. So if I read from left to right or right to left, it reads exactly the same. So that number is a palindrome. So let's get into the solution. The first thing that they have mentioned is a negative number will not be a palindrome. So let's get that done. If x is less than 0, then we just return false because we know that it's not going to be a palindrome. And I also think a single digit number, if it's between 0 to 10, between 0 and 9, it's going to be a palindrome. So let's get that away. Than or x is greater than or equal to 0, and that case we true. And then what I'm going to do is I'm just going to reverse the integers, and after reversing we just compare whether the initial value of x and the value that we have got after reversing is the same. So let's just make a copy of x because we are going to modify x, the number, and then we need to have a copy of x. Say reversed. Initially we'll start with 0. And it's just is just a simple reversing logic. While the number is greater than 0, what we will do is we will mod the number, that will be the digit, and we'll divide the number. And once we divide, that is going to be a new number. I have already created a video for reversing an integer. I'll put a card somewhere here. Will show the reverse integer. But basically what we are going to do is we have a digit which is going to be the existing number mod 10, and I'll explain this quickly once I finish writing the code. And then we to the number, the current number is going to be the number divided by 10. We need to store the reversed number. So the reversed number is going to be the current reversed number times 10 plus the digit. And I'll explain this in a second. And once we do this, the only thing that is remaining is going to be we need to check whether the reversed number is equal to the number that we have got. And then we can do that simply by saying return x is equal to first. Okay. So the important thing is this while loop. What we are going to do is we are going to just change, keep having the division of the number and the mod of the number. I'll explain this. If we have this number 1 to 1, the digit, when we get into the while loop the first time, the number is 1 to 1. The digit is going to be num mod 10, which is going to be 1. And the number then we divide by 10, so the number becomes 12. Reverse is going to be 0 initially. So reverse time 0 times 10 is going to be 0 plus the digit. So this is going to be. Now the number is 12 when we get into the while loop again. The digit is going to be num mod 10, which will get us 2. Reversed is going to be the current value of reversed, which is 1 times 10. That is going to be 10 plus 2. So 12, and the number becomes 1 because we divide the number by 10. Sorry. Uh, I have already created a video for reverse integer. I'll put a card somewhere here for that. This should work. Talking about the runtime, I think it's fairly easy to know that the runtime is going to be O of n, because we'll anyways go through the number entirely. I don't think the complexity is going to be of O of n. It's just going to be constant because we don't have anything used for storing. It's just a constant number. Space complexity is going to be a constant space complexity. Thank you for watching, guys. Have a good one.